Dear students, Assalamu alaikum and welcome back to Plant Physiology course. In today's video, we are going to discuss the chemical potential of water, and that is usually termed or known as water potential. So, water potential, it is the chemical potential of water. Now we already know the definition of chemical potential. The amount of energy per mole of a substance is known as chemical potential. And the chemical potential of water has been given a special term, and it is usually known as water potential. So from now on, we are going to use water potential for the chemical potential of water, and we are not going to use the term chemical potential as far as water is concerned. The chemical potential term is still valid, and as far as other substances are concerned, for example, if we are talking about some other solvent or if we are talking about solute, so we usually use the term chemical potential, but as far as water is concerned, we are going to use the term water potential. As far as the units of chemical potential are concerned, that how we are going to measure the chemical potential, we know that it is the amount of energy per mole. What might be the unit? Unit of chemical potential. In thermodynamics, it is mostly joules. Joules per kg, or it may be joules per mole. So we can write it J per kg or J per mole. So we can also write it like this. And even in the past, calories have also been used. So calories per kg and calories per mole. So these are the units for chemical potential, and the same units have been used for water potential as well. In 1962, these two scientists, Taylor and Slater, they recommended that we can divide the energy units of the chemical potential by partial molar volume. So energy units may be divided by partial molar volume, and what we get pressure units, because in plant physiology it has been a convention that for a very long period plant physiologists have been using the term pressure, like especially as far as the water is concerned, or osmosis is concerned, or movement of water is concerned from cell to cell, or in the osmometer. The old terms that have been used throughout the literature were osmotic pressure, diffusion pressure, deficit, and terms like that. So it was more appropriate to convert these energy units into pressure units. So this was the method used, and the recommendations of Taylor and Slater were accepted. And what happened, that plant physiologists started using pressure units for the chemical potential of water, or for water potential. So whenever we talk about water potential in solutions, or when we are considering cells or tissues, so we usually consider water potential in terms of pressure units instead of energy units. Here is the conventional definition or technical definition of water potential. So what is water potential? It is the chemical potential of water in a system, or if it is a part of a system. And how we express it, it is expressed in units of pressure, and then we compare it to the chemical potential, which is also in pressure units, of the pure water. and we do it at atmospheric pressure and at the same temperature. So water potential is the chemical potential of water in a system, or it may be a part of the system, and we express this water potential, and usually it is given the symbol psi, the Greek letter psi, psi, psi. So it is psi w for water potential, and it is usually expressed in units of pressure, as we have just seen above, units of pressure. And then it is compared to the chemical potential of pure water, which is also expressed in the units of pressure. So water potential is basically a relative term when we compare water potential of a system or part of a system to water potential of pure water. However, when we make this comparison, water potential of a system and water potential of pure water, this comparison is made at the same atmospheric pressure and also temperature. We are at the atmospheric pressure mostly, that is 760 millimeter of mercury, and we are also at the same temperature. Now the water potential of pure water is arbitrarily set to 0. So psi w in most cases it is equal to 0, that is of pure water, or we can say that psi w or water potential of pure water is equal to 0. Now this is a very handy expression as far as this 0 value is concerned, that psi w, the pure water potential, is equal to 0, and it helps us a lot when we consider the problems of water potential in cells, or when we separate two solutions through a semi-permeable membrane. So in this video we discussed a little bit about water potential, its so to say formal definition or conventional definition or technical definition, and we have also seen that water potential is usually expressed in units of pressure, and the water potential of pure water is set to 0. So it helps us a lot in understanding osmosis, and when we consider the plant water relations inside the plant body, that is when we are considering movement of water from cell to cell or osmosis in plant tissues. More about water potential and various concepts related to water potential in the coming videos. Thanks for watching, and see you in the next video.